My name is Amanda. I am a staff microbiologist at the Environmental Diagnostics Laboratory. Joining me is Dr. Rajiv Sahai. He is the director of the Environmental Diagnostic Laboratory, and you are attending part 2 of a 4-part series, How to Identify and Reduce Allergen Exposure. Part 2 is examining a building's health. So just a quick introduction to the series. It's a 4-part series focused on the building environment. Each part is going to be a 30-minute webinar focused on the building's environment and air quality. The presentation will be made available for all of you attending, and for those who you wish to share it for. Once the presentation has ended, it will be available to you. A certificate of attendance by EDLab and Pure Air Control Services will be provided to all of you who are attending. We also have a raffle for $5, $10 Starbucks gift cards. We will be holding polls throughout the webinar, so make sure you do your best to answer those polls, and we will see who gets them correct and choose 5 winners. And speaking of those winners, from part 1 we have Tajinder, I'm sorry if I mispronounced these, Tajinder Ajua, Timothy Leach, Reginald Ringgold Sr., Doyle Tiller, and Patrick Peck. Congratulations. A representative from Pure Control Services will be contacting you so you can claim your prize. We're going to do a quick recap for those of you if you did not attend part 1. Just so you know, it is available to you if you do want to go back and listen to the webinar or look at the presentation. But a quick overview. We did an overview of indoor environments and the indoor air, a historical perspective, an illustration on important aspects of this subject, prospect of good IEQ, indoor environment quality, and optimization of IEQ for health, energy, and comfort. So what we're going to cover is building health, what to examine, how to examine, and the outcome of the examination. And also for all of you to know, Dr. Rajiv Sahai has written a chapter in a book presented on this screen, Allergy and Allergen Immunotherapy. He authored chapter 6. If you would like more information on his chapter and the topic at hand, please feel free to contact us and we'll be more than happy to give you that information. All right, so I'm going to turn it over to Dr. Sahai, and we're going to get started on part 2.
Thank you, Amanda, and welcome to all of our participants. This topic is really important, and today we are going to get part 2 of this. Well, as you can see on the screen, the indoor environment, I have an observation through my experience and expertise working in this field, and I truly believe that environmental friendly building optimization secures health, hygiene of occupant and enhance the building performance, because building performance and hygiene and health, these are 2 very important components, and I believe that a few simple steps and few simple practices make it happen, and healthy occupants, more productive occupants. So that's the my experience, and that's what I have noticed.
Alrighty, so Dr. Sahai, can you give us a quick overview of what a healthy building is, and so we can understand?
Yes, as you can see on this particular slide, which is going on your monitor at this point, that there are 2 buildings, and well, I need not to say that which building is optimized, but let me give you a very precise definition of healthy building. Well, the healthy building is nothing but an occupiable space where occupants' functionality is at peak efficiency without any compromise. What it means that, like, you do not feel like, you know, not there, because sometimes you feel that, oh, I am breathing the wrong air, the water is not good, or my light is too bright, I am getting a lot of vibration due to noise. These are the few factors. So that's why I said you that, like, you know, the functionality at its peaks when you feel really comfort and cozy. That's the healthy building in a nutshell.
Fantastic. Thank you for explaining that. Real quick, we're going to start our polls. We're going to do our first poll. We're going to take a quick second and let's see. Alrighty, on your screen you should see the first question. I'm going to give you a couple moments to answer that. Remember, if you do answer these correctly, you will be entered into a drawing to win a Starbucks gift card. So try your best. The question has to do with what we covered in the last webinar. I'm going to give it about 10 more seconds, so make sure you answer. Alrighty. So as you can see, the answer was historical perceptive. That's what we covered last time, was the historic relevance and importance that this topic has had. So 29% got that correct. Alrighty. So let's go on to the next one. Interfering elements. Dr. Sahai, can you explain that to us? What are interfering elements?
Well, as I have explained in my previous slide, that what a good condition and how you optimize. Well, continuing to that point, let me emphasize there are certain elements that interfere, and those elements are very significant and important. And in order to get a good environment in terms of productivity, health, and hygiene, these are the elements which we must pay attention. The very first thing come in my head in the infrastructure, which includes the building engineering. I will be explaining a little bit later in my presentation. The second important fact is the HVAC, that stands for heating, ventilation, air conditioning system. Those who are not aware of that word, that is lungs of the building. So that is also a very important or integral part of the whole equation. The other one is the building water system, which every building, almost a functional building, have like water system in it, and that is also sometimes act as a carrier for the contaminant if it is not like maintained correctly. There is also a very significant amount of activity by the occupant that may interfere in the total quality of the environment where they are dwelling or they are living. And of course, there is another important factor, that's the environmental impact. So environmental impact, many a time it's a man-made or natural. So we'll discuss a little bit more on this topic as we go in our presentation.
Alrighty. So this next slide looks a little bit complicated. This diagram might be a little bit difficult to understand. Dr. Sahai, can you take us through this so we have a better understanding of what this is showing us?
Exactly. Like I said, that this diagram, well, obviously appears a little busy, but it's a lot of information and good information. And I'm going to simplify it. Like as I was explaining in my previous slide regarding the interference or interfering elements, this particular sketch is an attempt to explain that how we should go about evaluating or examining those point or those interfering factors. At the very first point I had said earlier is that like the total building structure. So sometimes the building is in the stacking mode, like 1 story, 2 story, and these stories are connected to each other. So there's supposed to be a perfect engineering for the optimization of building, including the building envelope, what we call building cover. And again, I will explain a little bit more on that how it is going to interfere. Then the second thing, I had focused on the heating, ventilation, air conditioning system. That is basically the lungs of building, because that is the breathing. Most of the building nowadays is energy tight building, what they commonly refer as. What it means that the building doesn't work with the natural ventilation, rather we have man-made air conveyance system put in there, which is sometimes good, sometimes not that good. But if it is efficiently managed, of course, that is having a lot greater benefit if it functions properly. So that is the second thing which I want to see, that want to show you that every building has that capability. The next one is the building water system. As you can see in this diagram, like I was telling you, this is in a stack building. So the water comes from a water supplier and then goes all the way up on the, the stacking different flooring. And if this system is not maintained properly, that might be a big carrier of various kind of bacteria. One bacteria come in my head, which is nowadays in news, that is called as Legionella, and that's basically a very pathogenic bacteria, and it is sometimes lethal. So that is the another point I wanted to show in this particular slide. The other one is the human activity. Well, when you are inside a building, you are active, you are doing something. For an example, you are doing cooking activity, you are just making other activity in the building that directly or indirectly is going to affect or influence that particular livable space or indoor environment. So we should be rather careful and doing the thing in a manner that it is not going to interfere too much. The last but not least, the environmental impact. The environmental impact on this building is not only from the inside, sometimes we call indoor source, but also come from the outdoor. If there is a lot of contaminant and if there is a lot of other, human activity or man-made activities going around that building, that might influence your building as a whole. So this diagram kind of give you an illustrative prospect that it is not only microbiological, it is not only physical, it is not only chemical, it is not only environmental, rather it is reacting with each other, and every point has its own influential factor, and we need to make sure that those things are managed in a way that buildings should function appropriately and optimize for sustainability.
Thank you. All right, so what do we need to examine?
That's a very good question, and like I was telling in my previous slide, that there are a lot of factors that interfere and that can be evaluated or examined in order to find out the total health or quality of a building. The very first thing we need to examine in the engineering proposition of a building, that how the building is made, what kind of building material is there, because some building materials are more prone for the microbial or other contaminant propagating than in comparison to the other. The second very important step is the environmental investigation. Like I was mentioning earlier, that some of the environmental contaminant and pollutant may be originating from inside itself, that is called as indoor, whereas many of them can come outside due to the man-made or natural activity. Some of the very good example of indoor origin of these chemicals, biologicals, physicals, or light, various kind of off-gassing from a building material, or from that prospect, lot of human activity like bathing, cooking, etc., that might be also influential for growing microbes, because people also say that mold is resistant for the moisture. So the moisture disbalance can also create some indoor pollutants or indoor contaminants flourish in the environment. There are supposed to be a two approach, or typically there are two approach. One is the proactive, other is the reactive. As you can understand, proactive approach is really good because you can find all the requisite equation that whether it is proning or indicating you to going to have some problem or not, because that is the best time when you can develop the baseline for your livable space or indoor environment. Whereas the reactive approach is an approach like when you start realizing some problem, you can start evaluating, examining various factors in order to dig out the problem so that it can be appropriately managed. How to examine the overall scenario? Well, there are two very good phases of it. The very first phase is the sample collection and transportation to the laboratory, because if you collect the sample in an adequate manner and transport it appropriately and promptly to a laboratory, then you will be getting a result which can be interpreted and a problem can be noticed, and then it can be appropriately addressed. Whereas the system surveillance is the other way, that you keep doing like these kind of sample collection or appropriate measures so that you can find out like how you are doing that. So these are some valuable point to examine the building in order to do the appropriateness for dwelling and functioning.
All right, well, thank you. All right, we're going to do our next poll real quickly. Let's see, it should be up on your screen at this point. It's going back a couple slides. So name one of the interfering elements in healthy buildings. I'll give you another about 15 seconds to give that an answer. Alrighty, and I'm going to close that poll out. The answer was all of the above. HVAC system, the building water system, and occupant activities all contribute to the interfering elements in a building. All right, so Dr. Sahai, we have to keep in mind there's an indoor and an outdoor environment. What do we need to look for in both of them?
Well, you cannot ignore either of that. That's the first observation. And well, to evaluate and examine the building health, you have to have the approach in which you can address the indoor environment as well as the outdoor environment. Some of the very common elements, at least you can evaluate or examine to get a total idea or at a glance idea about the indoor environment, is inspecting the building design. That's the first thing. The faulty design, when I say faulty design, meaning it is not designed appropriately, then it can be like, sometime accumulate moisture and temperature. And that is very important, especially for the microbial proliferation. So building inspection should be done for evaluating the building design. I'm not like going as an environmentalist to do the building engineering as a whole, but at the same time we need to understand that the engineering is suitable or it is not very adequate to prevent the microbial or other growth or contaminant as such in the building. So that's the first thing. The second one is the probing occupant observation. Many a time you receive complaint from, especially from the office building or maybe residential building, that you smell something. You think that you are going in the building and you don't feel good. So this don't feel good factor need to be probed really and taken seriously, because many a time people think that, oh, this is like, nothing is just happening. But why it is happening? That is very big question, and it need to be probing in order to go in the bottom of that. Investigating HVAC. That's the one of the main focal thing, as I said earlier, that out of sight, out of mind. Each day we experience something, and don't forget, earlier I said HVAC is lungs of the building, so it is breathing for you. So if you breathe the bad air, obviously it is going to give you a symptom. So investigating HVAC is going to elude the fact that what kind of air basically you are dealing with. So that's a very important point. Evaluating the contaminant. What it means that evaluate the contaminant, whether it is physical, biological, radiological, whatever. That kind of information is very valuable, whether it is a biological contaminant or chemical contaminant, because they can be harmful, or they can be at least influencing the health and hygiene. Celebritious assessment, that how clean is your environment where you are dealing. Health and hygiene is a total solution. So if you find that something which is out of whack, out of order, for an example, if you go in a very clean environment, very clean room, and all of a sudden you see on a wall there is something growing which is black, slimy in nature, that's not good. So we need to pay attention on that. Then estimating the PCBR, which is physical, chemical, biological, and radioactive pollutant source, that what kind of activity is being performed that inside a building. That is very important, whether we are dealing with a laboratory kind of scenario, we are dealing with the office kind of scenario, or just the residential kind of scenario. All these scenario which I said may have some activity which can fit in the PCBR category. So we need to emphasize, we need to find out that what are those activity. Building water system is the another one which I was telling you earlier, that like it can be carrier of various abiogenic and biogenic, both kind of pollutant. Many times you have biofilm, notice, in the water building system that can harbor a variety of microorganisms that may have an adverse health effect, and especially Legionella nowadays on rise. So we need to make sure that our building water system is not bringing any kind of odds in our building or in the livable space. And I also want to emphasize the energy audit optimization, because if your HVAC and other activity in the building is not adequate, then you are not only consuming more energy, but you are also creating problem, because this might be transformed in various kind of contaminant, and various kind of problem can arise from there. So far, the outdoor environment is concerned, again, many a time the HVAC unit, some of the units such as air handler, etc., is like depend, like the total solution can not only be like found just like evaluating the inside coil and things like that, but it need to be making sure that like the air intake and the point of intake, what kind of flora and fauna is around that, that can massively influence the heating, ventilation, air conditioning system. So I always emphasize that you need to required to evaluate that. The building envelope and roofing is a very important component of the whole equation, because that can help us to understand the building pressurization, so that like how the moisture and other thing is infiltrate or migrate in the building or in the occupiable space. That can also give a better clue. And obviously some man-made or the other pollution outside can significantly influence the indoor environment.
Alrighty. So this has a bunch of different kinds of examinations and assessments. Can you quickly take us through that?
Yes, like as I said, like when you start examining, doing the building health evaluation, the total health evaluation can only be done by a simple walkthrough, collecting sample, and then interfering or factor, or understanding the interfering factor. And upon the result, you can compare all these three in order to find out that what condition the building is in. The HVAC air conveyance system inspection is one of the very good in practice that lead you to the various problem. Off-gassing examination, testing simple chemicals and off-gassing in the occupiable space is the another one. Building envelope and roof assessment is the another way of finding out that whether the problem is within the inside of the building or it is just coming out from the outside of the building. And obviously water and other pipeline checkup can give you a lot of good information about like various pollutant and contaminant in the building.
Fantastic. All right, we're going to quickly go to our third poll. All right, so I'm going to launch that. You should see it on your screen. I'm going to give you about 15 seconds. What should you examine from both the indoor and outdoor environments? Okay, about 5 more seconds. Alrighty. So the answer was your HVAC system. That's what you can analyze and examine from both the outdoor and the indoor environments. Alrighty. So abiological and biological. Dr. Sahai, can you quickly take us through those real fast?
Yes, as the name indicates, abiological are those factors which must not have a biological origin of source. Some good examples are like suspended particulate matters, or noxious chemical, volatile organic compound, and other environment variants such as light, intensity, noise, etc. The biological pollutants are those which must have a biological origin of source, such as viruses, influenza, bacteria, fungi, and that protozoa and others such as pollen grain, mite, cyst, spore, etc.
Alrighty. Air samples. That looks like a bunch of different kinds of sampling techniques.
Yes, of course, the air samples are collected for evaluating both biological and non-biological. If you want to relay with the previous slide, a biological and biological, and these are the various commercially available sampling technique nowadays by which you can collect the air sample. In my next slide, I can show you some visuals so that you can understand. The spore trap is basically a mechanism of collecting air where the air is being drawn on a media, and that was directly evaluating under the microscope without performing any cultures. The second method is impactor, in that air is drawn directly on a microbiological media, and then later it is analyzed for bacteria or fungi or whatever analyte or the target analytes. The impringers are another media in which you can just take the air sample on a media, and then it is being cultured and analyzed, and then obviously the bulk or filtration system, you can either remove a portion or you collect various dust or amount of dust, and that can be analyzed in the laboratory for various analytes.
Fantastic.
Now, the surface samples are basically collected by the bulk, swab, and wipe sample. And in the next slide, you can go and I will show some of the very good example by which we can collect some swab sample from the surface, wipe sample, dust sample. These are some other way by which we can collect the sample. The next one is the water sample, that is like simply drawing the water from the HVAC or wherever the water source is, and we can analyze these samples. Well, so far the analysis of the sample is concerned, you can see in the next slide that there are two different methods by which we can analyze the slides. One is the non-culture method, which is the like direct microscopy or various kind of like, you know, the chemical testing, etc. I guess you have a question at this point, right?
I do have a question at this point. Just a quick another poll. Let me launch that for you guys. On your screen now, which of the following can be an air sample? So if you guys will answer that, I'll have it open for another about 10-15 seconds. Alrighty, I'm going to close that one out. And it looks like y'all got it right. The answer was all of the above. All of those different methods are ways of taking air samples. Alrighty.
Now there is second method, Amanda, by which we can analyze the sample. That's a culture technique in which typically the specimen is being cultured under the laboratory condition, as you can see in the first part of the diagram or the slide, that grow on a culture media plate, and then we analyze and identify those stuff. There are some modern technique. This is carbon source utilization. Sometimes people also call it fingerprinting or polymerase chain reaction, where we go the genetic level or molecular level to identify the organism or contaminant. So these are two very fantastic methods which is being typically used. Now in my next slide, I can show you some of the outcome of these kind of evaluation. For an example, if it is a microbial, you can see the bacteria, you can see various kind of airborne particulate. As you can see, I am dragging on the picture that like, this is the non-culture method slide, where you can see a lot of like, you know, skin cell and that kind of stuff. You can see insect biodetritus, you can see dust and mite, you can see pollen grains, you can see mold and fungi. These are some good example of the outcome of the various biogenic particulate. My Next slide, I wanted to show you that, like, how to evaluate the outcome of examination. Basically, that give you some good idea after evaluating the laboratory report that what is the severity by understanding the load of the microorganism or various kind of contaminant. That can also help you to pinpoint where the source is, and then obviously once you know source, then the causation factor can be determined in order to manage the whole or entire building. That helps not only assessing the hygienic impact, but you also prevent and give us clue to maintaining the health implication due to that.
Alrighty, I think we're going to do our last and final poll. It should be on y'all's screen right now. It has to do with the non-culture methods. Which of the following is considered a non-culture? I'll give you guys about 10 more seconds to answer that one for me. Alright, and I'm going to close that guy out. The answer was all of the above. Microscopy, ELISA, and PCR, those are all considered non-culture methods. If you have any questions in regards to the services Pure Air Control Services provides, or have any general questions and inquiries, our contact info is listed on the screen right now. Dr. Sai, do you have any closing thoughts?
Yeah, thank you very much for the time for all the viewers. And if you have any question, you need any kind of clarification, my email and the phone number is listed on this particular slide. Please do not hesitate. Contact. We can interact. We can help you out. And again, thank you very much to you, Amanda, and to all of our viewers.
Thank you, Dr. Sahai, and everyone. Thank you so much for attending. Please keep a lookout for that reminder for the part 3, and we'll see you next time.